Hello, I am Nitesh Pradhan from LabVIEW Programming. It is the first video of the series of LabVIEW signal processing. In this session, we will discuss about the sine wave and its component. Okay, I know all of you are very much aware about the sine wave functions in LabVIEW environment. Okay, but we will use the sine wave functions from signal processing toolkits. So for that, open your LabVIEW. Right click in the block diagram, come into the signal processing. In this signal processing, there is a waveform generation. In this waveform generation, this one is the basic function generator. If you will, if you will use this basic function generator, so you can plot sine wave, square wave, triangular wave, and sawtooth wave. Okay, but there is one independent sine waveform. So let's take this sine waveform. Right click, open the label. After that, press Ctrl H and move your cursor over the sine waveform Vi. Now you can see it's generated. Okay, the first, this one is for the frequency, is for the amplitude. This node, this is node. Okay, this parameter for the phase, and this parameter for the sampling info. Okay, we will discuss all those things, and this is the offset and this is reset signal. Now come here, right click, create control for the frequency. You can change it from this platform. Replace knob. Second one, for amplitude, come here, control. You can change it. Okay, you can replace it from this platform. Knob. Now the third one, it's for the phase. Create create control is for the phase. Now right click, come here and take waveform graph to display. Sorry, it is no need. Okay, just take waveform graph and place here. You can change the name here, sine wave. Okay, now place here and try to connect with the output. This error in and error out are optional. No need to connect any error in and error out. Now these are our controllers. These are our controllers, and this is our indicators. Right now, by default frequency has been set 10 and amplitude is 1. When I will run the okay, so it will generate a sine waveform. Look at here, it will generate a sine waveform. So it is time axis and it is amplitude axis. It is time axis, so you can change it into the second axis. So it's taking 1 second to plot this sine waveform. Just because the frequency is 10, that's why we are getting 10 sine pattern. We are taking 10 sine waveform pattern. Okay, in the one. If I will change, now it's 1, so we will get one sine waveform. Okay, one sine waveform. Why? The frequency is 10. So now here, how let's try to find how many how many points, okay, how many samples, how many data samples creating, how many data samples designing these sine waveforms. So for that, we can right click and we can come into the waveform. In the waveform, there is a get waveform component. Connect, right click, open the label, and drag it. Okay, when you will drag it, you will get this attributes. Okay, so set in the attribute, click and change it to the t0, that will the start time, and del t, that is a del t time difference between these 2 points. Okay, so now you know very well, one waveform graph, any kind of waveform graph, contain del t, t0 and y array. Y array contain all kind of the data values, you can say intensity or amplitudes. Okay, y array contain all kind of the data, all the data values. Okay, and t0, that is start time, and del t the time interval between two continuous data points. Okay, so let's count how many samples are here. So to find that sample, we will take array size, right click, create, sorry, indicator. We can number of sample. If we'll run this number of sample, so it will give us 1000 sample. So there is 1000 sample. Okay, so in this 1 second there are 1000 sample. So what is the 1 second there is 1000 sample, doesn't matter frequency is what. If the frequency is 10, so these are the 10 sine waveform. Okay, 10 sine waveform within 1 second, because the frequency is 10, that's why 10 sine 10 sine waveform is, okay, in 1 second is generating 10 sine waveform. If your frequency is near 5, so it will generate 5 sine waveform in a 1 second. Okay, now right click, create indicators, so you will get del t. Del t means that time interval. So let's try to find del t is the time interval, that 0 0, del t is time interval. So that means 0.00 0.001. So this, okay, so here the distance between 2 points, if I will write here point, just second, 0.1, okay, 0.1. So this difference, let's write 0.01, 0.01. Okay, so this is 0.001. Come here, look at here. So this is one data value, this is second another data value, third, fourth. So the time difference between these two data value, that is del t, and that is 001. Okay, nice. Again run, you will get all these data points. Now there is one more concept, and the concept is control this sampling informations. Right now number of sample is 1000. I am going to change the number of sample into the 100. Run, number of sample I have changed 100. Now it is 100 sample. Now these are the 100 sample. Now these are the 100 sample, but the sampling rate, is 1000. Look at here, the number of sample is 100. The number of sample is 100, but the sampling rate is 1000. Okay, now frequency is 10. The number of sample is 100 and the sampling rate is 1000. Why? This one is the sampling rate. That's why in this condition, we are getting only one sine waveform. We are getting only one sine waveform okay, in one sine waveform. And look at here, what is time interval? What is the second? It is 0.01 second. Why? Because just because of the sampling rate, our sampling rate is 1000. Our sampling rate is 1000, 1 kilohertz. Our sampling rate is 1 kilohertz. That's why our delta is 0.001. So okay, to plot 100 sample, to plot 100 sample with the with this 1000, sorry, is 1 kilohertz, 1 kilohertz frequency, it's taking 0.1 second. Okay, what happen if I will reduce it 100 sample? Now the 100 sample, sorry, now the sampling rate is 100. If the sampling rate is 100, so it is 0.01, it's 0.01. And now you can see these are the that 100 points which we are trying to plot with. Look at here, the second is 1, now it is 1 second, now it is 1 second, delta is 0.01, number of this sampling rate is, okay, no need, I will show it later, I will do it later. Now if I will reduce the frequency 1, so now it is 1. Okay, why second is 1? Right now why this is taking 1 second? Because the sampling rate and number of sample is 1. So sampling rate divided by sampling rate, okay, right now both the sampling rate and number of sample both are 100. So how can we find? So delta, when you will multiply delta, when you will multiply this delta, when you will multiply this delta, okay, this delta with the number of sample, so you will get that second, that time of the x-axis value, x time, okay, x-axis time. So it is 1 second. Okay, if I will reduce it, the sampling rate 10, so it will 0.01, and to plot 1000 sample, 100 sample with this 0.1, okay, time difference, it will take 10 seconds. Look at here. Okay, so it's a basic concept about the sine waveform. In the next video I will show you, I will teach you the difference between sine wave and sine pattern, sine wave and sine pattern. Okay, thank you for watching this video.